So read the question that's up here, and I'd like you with your partner to decide the answers to these questions. When you agree upon your answer, I want you to tip your cup upside down so that I know when you've got it resolved. All right, go for it. Your partner just turned the cup upside down and ran out of the room.
Observational units, variables,
oh, and maybe the observation units would be like or success, like winning. Because like that's what they want to get is like one color means one successful.
Observation units like what they're looking at, so they look at people. Is the color of the unit.
Yes, that would be the variable, and then like if they win, maybe it's the color.
So participating?
Okay.
You got all the answers? Good. Right.
Do you want to write it down?
Yeah, write it down so you have a record, but since we're recording this, we have that as well. So I think everybody has their cup upside down. So remind me the first name pronunciation. Anais? Anais. Want to give what you think is the answer?
Sure. For our observational units, we had like every match. The Olympics, we had variable, we had color uniforms, and series category.
Say it one more time. You got to use your squad leader voice. What are you going to use?
For observational units, we have a winner.
Winner? Anybody want to, there was two different answers. There was the matches and the winner. What do you guys think? The athletes?
Yeah.
All right, so we got three different answers.
We meant it like the competitors of each specific one. Does that make
Competitors?
sense? It just said like the competitors and
Yeah,
the
it should-
specific sports.
Lillian, what do you guys think? The competitors?
Wouldn't it be winners though, because it's on your recording?
So are we talking about the observational units?
Yes, ma'am.
So what are they recording? Like if you were going to make a spreadsheet, what would you be recording to index each row of your spreadsheet?
The color of the winner. It would be which match we were looking
The match we're looking at. From way within comes the answer, right? What about the variable being measured?
Uniform color.
Uniform color? Anybody else have something different? And is the variable categorical or quantitative? All right.
There's observation units, so they match.
Let's see, do I have? The observational units are the matches. So the way you should think of it is put yourself into that study and say, look, I'm going to be the recorder. And actually, in our studies that we run, there is usually a postdoc that's the recorder. And some postdocs do this well, and some postdocs don't do this well. But you know, how would they label things in their rows? They have all the data in columns, all the variables they're collecting. How would they index their rows? And it's by the match. And the winner of the match, the variable is whether someone's wearing red or blue. Whether the winner's wearing red or blue. And that's a categorical variable. So any questions about that? So remember, Major Adams already told us that the observational units is something that's very hard to understand. So I think the best way to understand it is just picture yourself recording the data into Excel spreadsheet. You're this postdoc. You got that job. So what would you do? Thumbs up? Ready to go? Right. Don't use symbols. Use words. And put your cups back up, and when you're ready, put your cups back upside down so I know you're done.
Either color does not affect. Color does not. Yeah, that's why I used impact.
Yep.
Why are you tired? You working hard today?
Listen, last night I worked out. It wasn't this morning. I had to alternate my time schedule.
We think Sergeant Major goes 2 times a day.
Say what?
I think Sergeant Major goes 2 times a day.
Yeah, I'll let you say that one.
Is this question tough?
Oh, I was gonna say.
What do you guys think, like, what does it mean to be the null hypothesis? What does that mean? Not for this problem, but in general.
Isn't the null just like counter to the original? So it's like if I say like all dogs run to tennis balls, then it'll be like dogs don't run to tennis balls, right?
Would be the null?
Yeah. Is that wrong?
Isn't it like what you think?
It's not wrong.
It's like what you think should happen? Like,
The alternate is your hypothesis of what you think might happen. That's a nice way to put it. So it's almost like backwards when you're thinking of, hey, do people with higher BMI deadlift more? That's the one we were thinking of earlier. So, yeah? Question?
Oh, isn't the null just like, it's happening by chance, like there's no
effect.
factors running into it, so 50% of the time the winner will be wearing red, or 50% of the time the winner will be wearing blue.
So that's drawing it out, that's drawing it out a little bit more, right? The null hypothesis, yes, correct, right? So the null hypothesis is if there's no effect, as if, and I like how Koika said it too, that, if something did have an effect, then that would be my alternative hypothesis. Are you good? So when I do these recall questions, they're really, really important because the evidence has shown that the more you touch the topic and the more you evaluate it, the better you learn. And so it's a deepening of the understanding. So I know that you just did the SIL, so I'm just reinforcing that with this. So these things are really important. Actually, there's data that shows the grades go up the more we do this. What more do you need, right? You win when we do this.
What's the p-value of that data, ma'am?
We're not there yet. Wait till the drama unfolds. Okay, questions about this? Anything shaky? Anything shaky, let it be known so that we can resolve it so that 100% of you get 100%.
is the no probability always like, it's always like 50-50?
No, it doesn't have to be. There was a nice example in your book about rock, paper, scissors, right? So there's examples that you can think of where it doesn't fit into this framework. But that's a good point because Major Adams told us yesterday that we spend a lot of time on this 50-50 because it's easier to understand that when we move away from the 50-50, which we're going to do today, it gets harder to think of things that are not 50-50. So let's take what he's told us and then, mitigate that. So 50-50 is the example we're using now because it's easy to understand and we can see things. All right, I don't have my colored cards yet, but let's answer this together. You guys didn't even talk to each other. You did? Not like my husband when I say, does this look nice on me? And he doesn't look at me and he says, yeah, it does. Wait a minute, you didn't even look at me. Discuss it among your partners so you don't feel like, decide like which one's true.
Yeah, no, I just don't know which one it is. I think it might be C.
What's your
Alright, how many of you think it was A? We gotta vote for A? As a pure mathematician, I can tell you that A is wrong because it's an irrational number and it's not supposed to stop at 2.7, but let's drop A. What about B? Nobody's for B? Please don't ever write that, like H0 is equal to something, because H0 is not something that's not a value that you're set equal to, okay? So it's a statement. So, are you gonna write that? Don't write that. All right, what about C? Got some votes for C. It's okay, because this is I actually haven't taught this class yet, but I've taught a lot of students, and I was guessing that this might be something that a student might think would be the parameter. What about D? All right, so let's think about C and why it's not the parameter of interest. Question?
Well, basically you're looking to see if red has an advantage over blue, not if they're equal.
Right, so almost like we're moving a little too fast. So the next step would be to start, once we have defined the parameter of interest, which is D, then we're going to set it equal to something for the null hypothesis and set it equal to something for the alternative hypothesis. So when you're asked for the parameter of interest, don't write C and don't write B. Definitely don't write A. Sometimes I say that and then it shows up. She said to write this.
So the parameter of interest is supposed to prove the null hypothesis.
You should be able to describe the parameter of interest entirely in words, no numbers,
Okay.
right? So that's a good trick. So when you put the numbers in, it's actually the next step. So all you guys are doing is moving one step ahead. So that's the correct one. Got it? So this is now you're going to use that parameter of interest, pi is equal to that probability, and then you're going to set it equal to something for the null and alternative hypothesis. So go ahead. How would you write that? So you wrote it in words already. We have it in words. How would you use that pi symbol to rewrite it with symbols?
And then for alternative.
Oh, they're like, yeah. Right. Let's take boards for this one. Put after you get to slide, put on. You have to watch boards today. What you think it is. And remember, this is like this is how. Remember, I told you those studies that have been done about people not coming in with a preconceived notion. This is how you change someone's mind. So don't think of it as I wrote down the wrong answer. You're here not to be perfect. You're here to learn.
Will win a majority of the time. So if that.
Where are the null hypothesis?
Yeah. Okay. Yeah. I guess.
And then have to stand up.
You're not just supposed to He made you do it. So did we have that red wings more? Is that what we had?
Yeah.
Right. So let's talk about that because we're going to talk about the two-sided. So I asked you to write it as two-sided, right? So remember when I had the Garmin? I think most of the answers on the board. So some of them have what we call one-sided test, and some of them have a two-sided test. So what's the difference between a one-sided test and a two-sided test? Do you remember the Garmin example I showed you?
So for the one-sided test, you're just looking like the p-value is how much of that like
curve is to the right of what your value is, or to the left with the two-sided, you're looking on both sides of the curve?
Okay, so you're putting it in relation to the curve. Can we think it without thinking about symbols at all? Remember my Garmin example with the question was, am I more active than the average person that wears a Garmin? And so what I asked myself is, where do I stand on this distribution, and what percentage of that is higher than me, right? So that's how we frame it. That's a one-sided. I'm asking about how much more active I am. So it puts it on that side. So that picture with the yellow bar there, like I said, commercial products have a nice way of displaying things because they figured it out, especially something like Garmin. You get what you pay for. So my husband was saying that you can buy cheap ones. He got me a cheap one. I'm like, no. The interface, that what they give you is data, and what they give you is important. And so I went out and got the Garmin for myself. You screwed up. You have to get me the Garmin. Oh yeah, this is being recorded, isn't it? Whatever I say about my husband is right here. All right, so let's look at that. What's the difference? Is it two-sided? I'm saying it's either equal to 50%, that probability is going to be, or it's not, right? So we're looking at both possibilities, that they lose more or they win more as being both sides. So that question framed in the Garmin context would be, am I more active or am I different than the regular population? Am I more or less active? So I'm looking at both sides. Good? So this one's a little bit hard, but this one's kind of reviewing your still. So I'd like to see what you would do. Change the matches to monkeys. Your still, right? What would you do if you had to go and set up a plan? I'm using language that's further in the book. We're going to hit that in the next few lessons, but reject the null hypothesis. I'd have to choose one. I've got to choose one of these. And it's going to be based on, it's not perfection, but it's going to be based on, you keep talking about the p-value, so it's going to be based on something numerical. It's just not like, oh, look at my yellow line, it looks a lot higher than everybody else. That's not good enough. So we need something that tells us that numerically that I am more active than the rest of the population. So here, what would you do to decide whether which one you're going to choose? So keep this language, rejecting the null hypothesis in your head. It's coming. You'll see it. You're going to choose one of those, H0 or HA. Which one are you going to pick? And how are we going to set up the steps to do that? Think about your SIL, what you did with the SIL, and then set up that plan. What did you do? And we did it also not just with SIL. Where else did we do it? So then you need to calculate the p-value. Something like rarely ever happens. Mostly like that. We'll get something like this. Something that people really care about, like cancer. Then if it is just a little bit above, is it good enough to say this works or not? It's not due to random chance. If it's not due to random chance, we'll take it. So there's a easy approach like that.
Because think about it, for the SIL, the blue is like how many monkeys didn't select the right box. It's like 10, but we didn't focus on 10, so how many got it right, which was 30.
So a good point was brought up here, like this is not like the Garmin example where I had the 99%. It's like, oh my god, it's a sure thing. So this looks like less of a sure thing. So we have to go through the process. Most applications are like that. Think about drug testing. So think about something like, hate to bring up cancer again, but I'm relieved I don't have it. But think of something like cancer. If there's a new drug and you test it and it has this kind of a result, and it is even borderline, and you have cancer, would you want it? Probably. So like we do care about the strength of the effect, and we also care about if there is an effect at all in some cases. So it depends on what we're doing. So not all things, most things don't come out with that sure 99% thing like I showed you. All right? So once you're done, turn your cup upside down so I know that you're ready.
Step 2, step 3.
I'm actually better.
Should put it in like a.
You tell them to run. You tell them to run.
Oh, yeah.
I mean, I used to.
We did another one, not just a still. Where did we do this? Where we had a plan set up and we did something and we checked whether we're gonna choose one or the other. Do you remember another example we did where we did something like this? Somebody say apple juice? Apple juice. All right, so computer's closed, please. Are you generating it? You're testing it?
I was gonna get the p-value.
I used the app. I was a little lazy. I didn't use R. But I'll show you what the results are. So what would you do? I just want the plan. What would you do?
So like instead of focusing just on like pure percentage of like red and blue, focus on red winning because that's what we're focusing on. And then do what we were gonna do, use R to focus and try and get the p-value for it. And then basically just kind of like see if it lines up with the null of being 50-50 or if it kind of goes against the null and says like it's above or below it.
Good. Now, let's suppose someone from the regular 206 came to you and asked you, how do I do this? What would you tell them step by step, like the nitty-gritty, dirty details?
Is it like find a statistic, simulate it, and then what's the strength of evidence?
That's correct, right? We want to do the little R code, generate that null distribution, drop our red lines. There's going to be lines if it's not equals. There'll be one-sided line if it's not, like my garment. And then check the area under the curve. It's a theory-based distribution, or the proportion of data that lies beyond that curve, right? Beyond those lines. Now, step 2, you can use R, or you can use plebes. Have plebes around flipping coins. Soon I will give you a prize in this class for something. We'll do something fun. There's a nice device called an Annoyatron. You can look it up. You might want to look it up early before you go home for Thanksgiving. Play pranks on your family. So this little Annoyatron has some statistics related to it too. So it's a nice statistics thing, and it plays pranks. 2 birds with 1 stone. But you know, it's fun to play with plebes. I had one last year.
Ma'am, why for the 2-sided test do you draw lines?
So how do you do that? Well, you have to look at distances, and you'll see in some of the formulas in your book, you'll see distances apart from things. You've seen that already inside the formulas itself. So we're looking at the distance you are away from things. So it's easier to look at the distance you're away from one versus the other. I did this with the app that's online, the One Proportion app, because I was a little lazy. And you can see, I love that it has this simulation on top of it that's overlaid, so you can see what you're doing. So what is this blue curve? What is that blue curve? That nice blue curve that would show up on the cover of a calc textbook. This blue thing in the background with the yellow things in the thing. Where does that come from?
That's a curve.
Hmm? What kind of curve is it?
Bell curve. No.
How did they make it? How did they know how to make it? So this is an app, so somebody has some code in there and they generate that curve. Where does it come from? Theory. It's a theory-based distribution. So it comes from a formula. So they have a formula inside there and it makes that curve. just so I know you guys love to think about 104, but it's that E stuff that you did in 104 with exponentials. That's where it comes from. And what about these things, the dot plots? Where did that come from?
Simulations.
Simulations. It's your plebes all flipping coins. Line up 10 plebes in a row, have them flip coins 10 times, and then you see what percentage of heads each one gets, and then you can generate this simulation. Our cutoffs in the book are 0.05, so that's not, I've talked to some of you about the little table. It kind of depends on what you're doing, whether you're going to say it's kind of borderline. I don't feel comfortable rejecting this and saying just because you wear red, you're going to win the match. Do you feel comfortable? So when I write up papers, what I'll do is I'll say, well, it was 0.07, it's borderline, take it for what it's worth, I give you the value. And you make your own conclusions too. All right, so any questions on that? I think we're going to do something fun today, especially people who like to write, because some of you told me you like to write. But, not you? Sometimes we get students who go into math because they don't like to write. That's the reason they go into math. And we find out they have to write everywhere. You have to write everywhere you are. It doesn't matter what you're doing. So this next few lessons that we're going to cover is about populations versus samples. So if I wanted to find out how much cadets at USMA like JJ's music. That's asking first place. So if I wanted to find that out, one thing I could do is I could go to all of JJ's friends and ask them, hey, do you like JJ's music? What would be wrong with that?
That's a bias.
They're his friends.
Well, you flock to you flock together in your life, so you wouldn't have that already similarity and traits.
Right, so how we sample makes a difference. Like if I went to all of JJ's friends and asked them, do you like JJ's music? And they all said yes, or they all said no. Doesn't matter. Your friends, good friends, are going to say yes? Okay. All right. So if they all say yes, then and I conclude and extrapolate from that, everybody at USMA loves JJ's music. What's wrong with that?
I think that
Obviously, his friends are gonna have the same like tastes as him.
Maybe, right? I don't know if that's true or not. We got a psych major in here, so we can find out it's true.
I mean, the people he hangs around with are probably gonna enjoy the same things he does and do the same things he does. So the odds of them liking his music are probably pretty
That might
high.
change when you get older. I don't know if everybody listens to the same music as me.
You're making a generalization.
Yeah, so I haven't really, what should I do if I wanted to really find that out? Like,
you should ask her.
You need
Wait.
a more randomized sample. It can't be like, you chose like a specific sample of a certain group of people instead of like randomizing it based on like the makeup of the core.
hold that thought, you guys are going to get a project, and I know I keep saying Major Adams said, but Major Adams said that one of the problems with collecting data for your project is some of you would just go to your team and do the survey on your team. Do not do that. Now that whatever he's told us, we're going to stop those gaps and not do those things, okay? So don't do that. So what I'm showing you now, I told you before that the CDC goes out. America's wonderful for this. We go out with mobile exam carts throughout the nation. We evaluate the health of the population. And they sample the United States, but then researchers take that data and they make inferences from that data. Well, the problem is they oversample some people, some subpopulations, and they undersample some. So there's a column with these weights in it, and there's a warning on the NHANES site that if you're going to use this for research to make inferences about the United States population, please be careful and use these weights. A lot of papers don't do that, actually. Which is why I say, if you want to do good research, work with a real statistician. So Colonel Watts, if you know her, she actually goes in through and is very careful about using these weights. I just wanted to show it to you, because this is, census data, things like that. We have to be careful making inferences about the United States based off of our sample. So we're going to do a little project today. We're not going to get through the whole thing, but I want you to get started. And I love this project because it's about writing. So this is a beautiful book written by a psychologist named Pennybacker. And he has evaluated writing. So we call this personality residue. The way people write the way people structure, even your barrack room has your personality residue left behind in it. I love looking in different faculty's offices to know a little bit about who they are. Yeah, anybody who's walked into my office knows who I am. It's a trap. I'm an extrovert. I'm trying to get you to come in there and stay in there. So there's music going, it's comfortable to sit in. So you can kind of learn a little bit about me just by seeing the office. Same thing from writing samples. And he dug deeper than that. He asked, does that writing sample actually tell me a little bit about that person? He got so good at that he actually has been hired by companies to find anonymous letter writers. And on this, see this exercises up here? There's a bunch of little apps that you can play with where you can do writing samples and it gives you a synopsis of your personality, matches with Ocean. Who else in here is psychology? Anybody else psychology? So the Ocean test that they give, it matches up with that, and I think it does a pretty good job. But it has other little things on there that are pretty fun to play with. So today's exercise is going to be about reading something and evaluating something from writing.